In this video, we're going to show you how to extract airfoil section data from selected nodes using the node ID on-off see pane dialog. So for this case, we're going to load a techplot file of a F16 CFD surface panel model that happens to have stores. So this is the model. Once it's loaded, we can rotate it into a desired view. Now, as with the other methods to extract airfoil section data, we need to ensure that the model is oriented in the proper frame, meaning that it's going down the x-axis. The fact that we have a left-hand side model here, which is still not the appropriate ZAERO frame, which requires that the model lies on the positive XY plane, the right hand side here, it's okay because we're just going to extract airfoil section data from the main wing here to show you an example. So what we can do at this point is, since we have these components in separate zones, we can turn off the Station 4 370-gallon fuel tank here and the horizontal tail, so that when we take a cut through this region, we're not picking up anything from under the wing or the horizontal tail. So we can use the zone settings window, come down here, and we see the horizontal tail is here. We can turn it off and you see it disappear in the model. Likewise, the Station 4 370-gallon tank, we can turn that off. So we have this. So let's just say for we want to get the airfoil section at this location. Then we can go to the slice plane, choose a Y plane, and then select a node in this region. Okay, so we have a leading edge flap, the main wing, and a trailing edge flap, but we can extract the airfoil section through all of it. So we click on Extract Slice Data, and then we can see here this green line from the extracted slice. And if we want to view that by itself, we go back to the controls view, select zone settings. We'll turn off every station except for the one that we just created, which is zone 26 here. And then if we look at it from the side, turn on the nodes, then we can see the cross section of the F16 wing. So we go over to the node element variable ID on-off pane, and here there's an options button that we can do many things. So we'll go over several of them here. The first one being that, for example, delete an entry. So whenever you, if you click on the nodes, and incidentally that we don't have scroll bars in ZONA-MV. If you want to scroll the view, you can actually just grab it and move it, and to get back to the original default position, you just double click in the view and it snaps it back into its original place. So this is just a quick way of scrolling if you happen to have the window sized down and you can't see all the controls. So if we click on the nodes button, then we can come in on the model and select points. Alright, so let's say I'm going to select the leading edge and the trailing edge point here. So I get 2 points in the list box here. Now, one option I have is to compute the center point. So if I select that, it tells me that the center point is located at 28 minus 5.3, 7.6 for the Z. Alright, so that's one feature. If you happen to have 2 points, you want to get a center point, you can get it that way. Another option is to, well, we can delete individual entries in here. If you highlight one, you can select to delete an entry, or you can clear all entries and it will clear out the list box. So for getting the airfoil section, as we come down here, we see that there's a get the AEFACT X coordinates in % form, which is what we need to define the X coordinates in the ZAERO Aifoil option or for ZEUS. So this particular feature, you need to select points from front to back. So I have nodes on here, and it doesn't have to be from a cut like this. It can be even from a top looking down on the wing. If you happen to have cuts along a line that you can use, you can just select those points. But in this case, we have the slice here, and as an example, I'll just go ahead and pick some. We won't have to pick all of these. This is just an example. So I'll come over here, pick in the middle, come towards the trailing edge, and then pick a last point here. So we have these points selected, and then we can, so when you select this option here for AEFACT X coordinates, it will be based on whatever values you have in this list box. So I will go ahead and select that, and then we see here that it gives us an AEFACT that starts from 0 and goes to 100, and these are the percentages for each of those points based on the X direction. So you can copy this by highlighting it, right mouse clicking, highlighting it, right mouse clicking, and say copy, and then you can go over to your input deck and paste it in. So that's one way to get the AEFACT X coordinate values for defining an airfoil section. Some other features we have in here, if you want to get the ZAERO, like for a wing, the leading edge, the ZAERO has two entries to define the wing root chord definition and the wing tip. So you can use this feature simply by, if we clear all of this, let's say this is the front of our wing, we pick the front point, and we go back to the trailing edge, pick the back point again. So we have 2 points in here, and then if we click on output the ZAERO 7 XYZ and length, you see this entry that comes out here. Then we can copy this guy and paste it on our ZAERO 7 card, and it'll give you the XYZ of the nose point and the length of the root chord or tip chord of the wing we're trying to set up. So that's another little useful feature that you can use. Likewise, when we have selected points, you can output the half thickness in percent or camber. Now, there are some more powerful options in here. For example, since we have a slice of the entire section here, we can, let me clear out the list box. There's an option in here to select all the nodes from the active zones. So since our slice zone is the only active zone, if we select this option, it will pick up all the points for this particular airfoil cross section. So it says here that there's one zone with 358 nodes. Do you confirm to add it to the list box? We say yes, and it adds all of those points, the IDs of those points in this list box. Now from here we have an option that you can auto compute all AEFACT for Aifoil input for ZAERO or ZEUS. So this will give you not only the X coordinate percent, but it'll also give you the half thickness and camber values at each one of those. So if we select this feature, we see here it'll output 3 AEFACTs, 101 to 103, and this guy contains, and I think it's built in at 55 points, so we go from 0 to 100%, and it'll interpolate through these points and give you these X coordinate and then the half thickness that are interpolated, and the camber, which is down here. So you can copy this input into your ZAERO or ZEUS bulk data input deck and use that as the airfoil definition for this particular station. And then some other options that we have in here, outputting C-bar elements. That simply means that this was an option for Astros, that which is our ZONA's structural finite element analysis solver, and if we happen to have picked points in the model and we want to output C-bar elements between those points, this is a quick way to do that. If I do that right now, you'll see that it does all 358 points, and it'll just output the a C-bar element between each of these points. All right, so that's just a feature that's there for in-house reasons, but it can be used if needed. And then finally we have some other features here. We can output the C07, the L span for a span on the wing. If we happen to pick, if we take a slice in the span-wise direction for a wing, we can use this to obtain Y coordinates, and it'll interpolate between the points, and it'll ask you how many span-wise points cuts do you want. Same thing for the X coordinates here. It can be used and it'll interpolate. So if I would have, for example, picked 10 points here, then I can use this to get the X coordinate AEFACT values in percent for, say, 21 points, and it'll interpolate in between, and it will also sort those points so they don't have to be selected in order. Finally, these last three are if you want to get the X, Y, Z coordinates of all the points in the list. So let's say, for example, we want the X coordinates of all these points sorted in ascending order. I can just click on that now, and it'll output. See, there's some duplicates for each station, but it'll sort them in ascending order. So we get all 358 points out. So that's how you can use this, these features.